Okay, for the warm-up, let's do the inverse trig operation on the given ratio. So we're going to start by drawing our picture. Cosine inverse is only defined for quadrants 1 and 2. So I only draw half of the quadrants. Cosine is x over r. And since this is a positive fraction, we know we're in quadrant 1. And so what angle would give you this x and r? Well, that would be a 1. So this would be 30 degrees, but we need our answer in radians. So that is pi over 6. Okay, so another cosine inverse, just quadrant 1 and 2. Still x over r because it's cosine, but now with that negative, we're in quadrant 2. Still a reference angle of 30, but the angle of rotation would be this angle for our answer. So if I think about pi, and let's do this in radians, and pi over 6, our angle is going to be pi minus pi over 6, but I need a common denominator. So the angle of rotation is 5 pi over 6. All right, sine inverse is defined for quadrants 1 and 4. That's y over r. Negative would be quadrant 4. So the reference angle here is pi over 6 again. And because of the restrictions on the inverse, I wouldn't go around in the positive angle direction. I can't go over here to quadrant 2 and 3. We're just going to take the negative angle and go clockwise pi over 6. All right, and lastly for tangent, well, first I need a fraction. Tangent is quadrants 1 and 4, y over x. Positive would be quadrant 1. This triangle is created by the pi over 4 or 45-degree angle. Okay, so we're going to put that together today with multiple steps. We're going to do more than one triangle per problem. So we're going to go to page 17. And let's start with number 2. Don't worry about number 1. We'll come back to 1. For number 2, I start on the inside. So I need to figure out, this is not an inverse, so I get every quadrant. I'm going to label the quadrants pi and 2 pi to figure out that 5 pi over 3 is in quadrant 4 with a reference angle of 60. So sine of 5 pi over 3 is a value of negative root 3 over 2. And now we're going to still do sine inverse. So arc is the same thing as inverse. So now we got a second problem here. We're going to do sine inverse of negative root 3 over 2. It's actually kind of nice. I can use the same picture, except not use quadrants 2 and 3. So the angle that gives us a sine inverse of negative root 3 over 2 is clockwise, so negative pi over 3. All right, let's try number 4. We're going to start on the inside. Cosine negative pi over 3 is all 4 quadrants. That's not an inverse. So I draw my negative pi over 3, which is in quadrant 4, this way. That's 60 again. So cosine of this picture is 1/2. So now we've got cosine inverse of 1/2. Let's draw a new inverse triangle. So cosine inverse is only quadrants 1 and 2. It's a positive x over r, so that's quadrant 1. And so this picture would have been made from a 60-degree angle, but in radians. So pi over 3 is our answer. Okay, let's try 5. Pause the video here. You do the inside first. Find me sine of 5 pi over 4. Okay, so 5 over 4 is a little more than 4 over 4. It is a 45-degree reference angle, so we get -1 root 2. So sine is y over r. Well, now I need sine inverse, and that's restricted, so I'm going to draw a new triangle in quadrant 4 because we went negative y over r. And so that would be an angle here of negative pi over 4. So it's the same kind of problems like the warm-up, but just double step. Sometimes you're doing the original trig function, and sometimes you're doing the inverse. All right, let's try page 18. Starting on the inside, tangent inverse is restriction. Tangent is y over x. Positive would be quadrant 1. And 3 and 4 are not one of our special angles. So this kind of problem, I just need to use my Pythagorean theorem to find the radius. So let's see, we've got x squared plus y squared equals r squared. So the radius is 5. So now sine of this picture is going to be y over r. All right, let's try number 2. Draw a sine inverse, because that's restricted, y over r. R is never, ever, ever negative, so I know that the y segment is the negative value, so that I label -5. Now I have to find the x, so x squared plus y squared equals r squared. So x is the square root of 39. Cotangent is x over y. Negative in the denominator looks a little funny, so we're just going to make this a negative fraction. All right, for number 4, root 3 over 3. Well, I know that comes from one of our special triangles where it's the same thing as 1 over root 3. So that might be easier to use. Oh, but root 3 is never the radius. All right, well, let's just go with it. So cosine is x over r. It's a restriction. And it's going to be quadrant 1 because it's positive. So we've got x squared plus y squared equals r squared. Y squared is 2. So this is, the y is the square root of 2. So this is not a special right triangle, even though I thought it would be one because of the 1 over root 3. So sine is y over r. So just as a note, 1 over root 2 we know is equal to root 2 over 2, and 1 over root 3 is equal to root 3 over 3. Those are just good to have to be able to switch back and forth between the forms for these inverse problems. So this would be a good memorize or recognize the equivalent fractions here. All right. Let's try 5 and 6. So you pause the video here and try those. Your tangent is, well, is quadrant 1 and 4, but this is a positive y over x. So x squared plus y squared equals r squared. This will be the square root of 101. So cosine is x over r. All right, for number 6, now I've got some radians here. Do a regular cosine, so all 4 quadrants. Negative pi over 4 is quadrant 4. So this inside fraction equals 1 over root 2. So this question is really asking me for the sine inverse of 1 over root 2. Sine inverse is quadrants 1 and 4, y over r. So this picture comes from a pi over 4 reference angle. Okay, so now your practice is selected problems on the next 2 pages. You need extra space to draw the triangles and the restricted quadrants and the not restricted quadrants. So grab a piece of computer paper or your notebook and try these